All right, so this is the second video, and we are on graphing quadratic functions in the form f of x equals x minus h squared. So first step is to identify our vertex, and it is at 6, 0, right? Minus a positive would make that a 6. That also tells us that our axis of symmetry, let me label that, is at x equals 6 because it's always x equals h, or the x coordinate of the vertex. This one opens up, or upward if you want to say it that way. And then we also can talk about the shift. This is going to shift right 6, right? We're going to shift to the right 6. Remember, we were on this previous one. It shifted to the left because we were at negative 5, 0 for our vertex. Now we're at positive 6, 0 for our vertex here. So it's a shift of 6 to the right. Now I'm hoping that you're picking up on how we've been graphing this by just using the shift, and you don't even really then have to worry about finding any other ordered pairs. Because if we count 6 to the right, we're going to be here, right? At this was at 6, 0, so now we're at 7, 1, and we're also at 5, 1. So here's the graph that we were supposed to be graphing on this question. Oh gosh, I didn't hit that very good. Our axis of symmetry is through our vertex at x equals 6. And you guys, this is graphed, right? This is all we need to do with this one. Okay, so now we're going to talk about what happens when a is not 1 or negative 1, because so far the a has been a 1 or negative 1. We can still compare to our original graph, but this time the a just means that we're ending up multiplying by something, and it makes for a more narrow or wider graph. So basically what this is saying, if the absolute value is greater than 1, it will be more narrow, and if the absolute value is less than 1, it's going to be wider. So this would be like a fraction, right? So on this one, it would be like a equals 1/2 or something like that when it's less than 1. And notice its absolute value. It can be a negative 1/2, and it meets that same criteria. It makes for a wider graph. So the bigger the denominator in this case, the wider the graph gets. And on this, the greater the number is than 1. The bigger the number gets, the more narrow our graph will be. Okay. All right, so let's take a look at this. We are going to compare the f of x equals 5x squared. Oh, did I talk about the vertex here? On this graph, the vertex will be at 0, 0 every time because we don't have an h or a k. So that means 0 for both. So our vertex is at 0, 0. Of course, I just told you that. The axis of symmetry is going to go through the x coordinate of the vertex, so it is going to be erase axis of symmetry at x equals 0. It opens up, and it's going to be narrower than our parent graph, y equals x squared, right? It's going to be more narrow than that because we're basically multiplying whatever we get for x squared by 5. So that makes for a pretty skinny graph. Okay, so we're just going to go ahead and graph 0, 0. And then I'm going to look at this with some ordered pairs. I feel like it'll make more sense to you. If we use negative 1 and positive 1, then we're going to take 5 times negative 1 squared. So that's 5 times 1, or 5. 5 times positive 1 squared is also 5. So when we graph this, we're at negative 1, 5, and 1, 5, And right off the bat, you can see that it is very narrow. And in fact, kind of hard to draw with a curve here at the bottom, right, for your vertex. And so here's one side. It's not really supposed to have a curve right there at the top. That's not looking too good there. I'm waiting for that to leave. It's a little weird how I drew it, but anyway, you get the idea. Drawing the very narrow ones are a little bit difficult, honestly. I'll put that, scoot it over a little, won't look quite as bad. So that is our graph, right? We just really multiplied by 5 in order to get those 2 points that make this very narrow graph. Okay, next. So this one has a fraction, which makes it wider, okay? It also is going to open downward with a vertex at 0, 0. It's going to be wider than our graph of y equals x squared because it is a fraction. And our axis of symmetry is at x equals 0 again. Okay, so let's look at this one. Now, on this one, I'm going to use some different points for graphing purposes, and I think you'll understand why once I show you this. Okay, vertex at 0, 0. We know that's going to open down. If we go on either side of the vertex and choose some points, it would be best to choose either -2 and +2, or to choose -4 and +4. Now, if I choose 4s, I know for sure they're going to work, but you know, if I square -2 or 2, I'm going to get a 4. So -1/4 times -2 squared, right? So that makes that 4, right, when I square the -2, and 4 times -1/4, right, is going to be at -1. And same thing happens when I take 2 squared, right? So 4 times -1/4, and you guys can always do that with your calculator if you want to, is going to be a -1. And so that's really all I need to graph this. I'm going to have a point at -2, -1, and right away you can see that this definitely gets wider than our previous graphs. Our axis of symmetry is still at x equals 0. And I'm making a very squiggly side there. Sometimes it just happens when I'm trying to draw these. You get the gist of that, I think. I just can't seem to keep from doing that. Okay. So there we have it, right? We've got that axis of symmetry drawn. We have our wide parabola opening down. And so that takes care of all these different things that we're talking about. All right, next. Now we're going to graph quadratic functions in the form f of x equals a times x minus h squared plus k. And that means that we can have, right, we're going to stretch or shrink the graph, right? It's going to get more narrow or wider. We may have an h and we will have an h and a k, so it's going to shift up or down, left or right. And so lots of things going on based on our parent graph of y equals x squared. Notice that our vertex is always at hk, so it's easy to identify, and that's nice. And so let's take a look at this. Oh, and our axis of symmetry is still x equals h. It is every time, whatever the x coordinate of the vertex is. That's how that works. Okay. So there's some things I can tell just by looking, and that's the whole point of this, is learning, oh, I can find my vertex and make this very easy to graph. And you can use that basic graph, but when you're multiplying by the 4, it may or may not be confusing, but you know, you can do that. And let's look at what our basic graph would look like, right? It would be this, opening up. Okay. Now, let's identify what we know. We know our vertex is at positive 4, 2. Remember the k stays the same sign. We know that this opens up. Our axis of symmetry is at x equals 4. We know that it is narrower than y equals x squared, which we have graphed over here, in fact. And so also it shifts, right? It shifts right. That you can see that from the vertex, right 4 and up 2. Okay. And we also have an A of 4, so it makes it a very narrow graph. So let's take a look at this. Let's graph 4, 2. And then let's look at some x coordinates on either side of that 4. So at 3 and 5. And I'm going to show you how to find those if you just want to substitute those in. Now you can do the counting, but you would have to also multiply by 4, right? Because this is going to become narrow. So you might like plugging in the points better for that. So 3 minus 4 is -1. -1 squared is 1. 1 times 4 is 4. 4 plus 2 is 6. And so you see that we're going to find that same number for the next one because we're putting in a positive 5. So 5 minus 4 is 1. We square it. 1 times 4 is 4 plus 2 is 6. So we're at 3, 6. And we are at 5, 6. So this is our solid one that we're going to draw with the pink. All right, let's see what we can do. Okay. I have a terrible time drawing these really narrow ones. I have either squiggly lines or something, but this should be curved at the bottom. It's definitely not an absolute value. I think I'm just making it worse possibly here. And then our axis of symmetry, I just really don't like that. Take that all off of there. I don't know if you guys have the same problems with that as I do, but it's a little tricky. Okay, our axis of symmetry is at x equals 4, and we want to make sure that we put that on the graph and be sure that you put it on the graph when you're working on your homework on My Lab because you don't want to miss it because you didn't put your axis of symmetry. All right, so that's it. There's several things to find, right? The vertex, the axis of symmetry, notice that it's more narrow and it shifts 4 and up 2. And you can look at this right from your vertex 1, 2, 3, 4, 1, 2. But on these two, you can't really count them because of the times 4 part. Okay, now let's go to the next one. Oh, I'm going to stop the video, in fact, and finish this lesson on the next video.